this online training session, FME for MapInfo Professional users from OneSpatial. My name's David Eagle. In today's agenda, we'll look briefly at OneSpatial and Safe Software. For new users, you'll get to find out what FME and MapInfo Professional are. And for users who've been working with these products for a while, we'll look at the detail. So, support for MapInfo's formats in FME, how you can style your MapInfo data, approaches to working with raster data through clipping and mosaicing, and extending MapInfo Professional. And by doing this, we'll look at FME custom formats and how you can extend your FME license into MapInfo Professional. OneSpatial, formed in 1969, has offices in the UK, Ireland and Australia. Our focus is on data quality and accuracy, and we have our own software products and resell others, such as FME, to achieve this aim. We have a number of high-profile customers, as you can see. Safe Software were formed in 1993 and have their offices in Vancouver, Canada. Safe are the makers of FME, and it's used by thousands of geographic information professionals globally to transform and translate their data so that it's provided where, when and how it's needed. FME is the industry standard tool and interacts with all our discipline's major vendors. When it comes to FME capability, OneSpatial is a value-added reseller and has been for over 10 years. We support both FME Desktop and FME Server and have a number of FME certified staff globally. Our FME services encompass facilitated product evaluation to help you get the most out of your evaluation period in as efficient a way as possible. We also provide FME consultancy, public training courses and ones tailored to your needs, as well as technical support. So, what is FME Desktop? Well, when you buy FME, you buy a processing engine that allows you to both transform and translate your data. This simple diagram represents the FME engine, and hanging around the edge of that engine are the different formats that are supported by FME. FME 2012 supports over 275 of these formats. What the engine does is understand exactly what formats it can work with. So this format here, let's imagine it's Maplnfo tab. You can read the data, pass it through FME and write out an Esri shapefile. In another process, you could read an Esri shapefile and write that to MicroStation DGN. But FME knows that this format over here, NTF, you can't write into. However, you can read out of it. If you'd like to know more about the formats that are supported by FME, just go to safe.com/formats and I'll give you some more URLs and some detail at the end of this session. Essentially, FME is a centralized, semantic and interoperable tool. MapInfo Professional, on the other hand, is a GIS tool. It allows you to perform powerful spatial analysis, understand your data better, and ultimately create custom maps and content that you can include in reports or give to customers. It's the world's premier desktop mapping application. What do you get when you buy FME? Well, on the left hand side you can see the Universal Viewer. This gives you the ability to open any dataset at any time and many formats all in the same window at the same time. You can simply do a file open and open up a MicroStation design file, an AutoCAD DXF, a MapInfo tab file, an Esri shapefile, and connect to several tables in Oracle Spatial if you require, and show them all in the same window at the same time. The Universal Viewer is a very powerful inspection tool, and more recently the Data Inspector has been created, which allows you to look at your 3D data. FME Workbench is where you author your processes and use small tools called transformers to change the data's structure. we'll look at the workbench in a lot more detail in this session. The Universal Translator will be familiar to Maplnfo users because it's shipped with Maplnfo for some time, but with FME it comes as a standalone tool that allows you to translate all of your data to any of your required formats. You may be aware that you can run FME on the command line as well, which means that you can build batch files and use scheduled services to run several jobs one after another. Another capability that you get out of the box is an application extender. Depending on the other tools that you use, you can extend those applications, and we'll focus on MapInfo Professional in this session. Let's look at format support. So, if you search for Maplnfo when you're using FME, you'll find that there are 4 readers and writers. Let's do that now. First of all, we'll launch FME. We're using FME 2012 today, and if we create a new workflow and generate a workspace, you'll see I can type Maplnfo and I get access to 4 formats. If we do this in the IntelliComplete dialog box, we get a shortened list. If we actually go over to the catalogue and search, the same is true, we get a shorter list. You can see Maplnfo MIF-MID, Maplnfo Spatialware, and 2 Maplnfo formats for tab, mfal and mytab. We'll look at the differences between these 2 formats shortly. So, the Maplnfo Spatialware reader-writer was generated to provide Informix and Microsoft SQL Server users with access to a spatial geometry type, SW geometry. That now has admittedly been largely superseded by spatial technology advances on the database itself. SQL Server Spatial 2008 and Oracle Spatial have rendered the Maplnfo Spatialware reader-writer largely unnecessary, but it still exists for legacy reasons. Maplnfo MIF is a reader and a writer, and it's an interchange format. Those of you familiar with Maplnfo will know that the MIF file contains the vector information and the MID file contains the data. It's often used and supported in proprietary systems that accept MIF-MID for input or they export to MIF-MID, and often that's coupled with another format, DXF. So it's worth knowing about this format for exporting and importing data into other systems. I mentioned we'd talk about Maplnfo's tab file format. There are 2, and the differences can be important. The mfal, or Maplnfo tab reader writer, is largely the one that I would recommend, as it uses the official libraries from Pitney Bowes software. It does produce a better spatial index than mytab, but there is a performance cost. Those of you that work with Maplnfo know that there are a number of files that are found in a tab file. The tab file itself is the header information, the map contains the geometry, the dat has the attribution, and the ID links the 2 together. If you have 1 or more columns in your data that has an index on it, the IND file will exist as well. The mytab reader-writer is slightly different. It actually is an open source library to access the Maplnfo tab format. One of the main benefits that you'll find is that it has the ability to read the MDB component of a Maplnfo tab file, where this exists instead of a DAT file. So it's worth knowing that this capability exists on the mytab reader. If you'd like to know more about these reader and writers, then go and take a look at FMEpedia. It's a really useful resource, and there's lots of information and specific pages on these 2 formats. Now let's take a look at styling your data for use in MapInfo Professional. There's a number of options to styling your data. It depends on the geometry that you're working with. You'll see that there are a number of geometries available to use in MapInfo. Points, lines, polygons, text, each with their own capabilities. You can even apply themes to your data with FME. We'll start simple and make our way to more advanced styling methods. As I said, there's a number of options, and if you're new to FME, then you can quite quickly get up and running. The Maplnfo support for styling is quite rich. So what we're going to do initially is start with a transformer called the color setter. If you've been familiar with FME for a while, you'll know that the pen color setter and the area fill color setter were the transformers that you might have used in the past. Note that there is now an English alias name applied in FME 2012 to make finding your transformers simpler. If you use and search for the old transformers, they still exist, but actually the transformer that you'll get on screen is the color setter. It's new and it includes both the capabilities of the previous transformers. Let's take a look. So we'll open a workspace. Here we can see the simple styling workspace, and we'll just zoom extents so you can see that in a little bit more detail. I've used a transformer called the Creator, which if you haven't used before is worth looking at. It allows me to create some geometry rather than having to create data in my GIS first. So here we can see I built a polygon with a series of coordinates starting and ending at the same coordinate in order to close the feature. It's a simple square. I'm just creating one, but I could create as many as I wanted to. The color setter then, once the feature arrives, allows me to set both the pen and the fill color. The pen changes the color of the border, the fill the center of the polygon. This, you can see, is an RGB value, but it's not the traditional approach to styling and working with red, green and blue values. To find that, you have to look inside the color swatch, and now you can type in the values that you would ordinarily expect, or you may extract from something like a photographics package. If we take a look, SAFE's approach to styling means that anybody, even if you don't understand the traditional approach to RGB, can mix a colour palette. Here we have 100% red, 0% green and 0% blue, giving us a red colour. Here we have 100% red, 54% green and 13% blue. This gives us orange. Now you can see that if you add values between 0 and 1, you're getting a percentage of that red, green or blue to mix your colour palette. So the colour setter applies the style and writes the data out. In this case we're writing out to Mapinfo tab. So let's run this process and write the data out. I've forced the data to exit to the universal viewer so I can inspect it, and we can see we have an orange interior with a red border. If I close it down and right click on the destination dataset, now I've run it, I can open the containing folder, right click, open with and choose Mapinfo. And I'll show you the output in MapInfo Professional, and this is the latest version of Mapinfo, version 11. Here you can see the same feature with the same colours applied. The reason I'm showing you it in the visualizer and in Mapinfo is because for some formats that aren't quite as capable as Mapinfo when it comes to styling, the results in the application that you're using may be slightly different to what you can see in the universal viewer. And that's because the universal viewer will represent exactly what you've done, whereas once you write into the format you're working with, that format may constrain the capabilities. Mapinfo, with its rich styling capability, for example, supports 16 million colours, whereas AutoCAD only supports 256. So in this case, styling the feature to a shade of orange may not have got exactly the same shade of orange if I'd written into AutoCAD. So it's worth noting that some formats do have constraints on their capabilities. Now let's take a look at another process. An intermediate styling method may be to use the Mapinfo styler, a dedicated styling tool for working with Mapinfo data. If you're interested in some of the other formats that provide rich styling capabilities, then the DGN, DWG, KML and PDF stylers are interesting to take a look at. And these are all transformers that have appeared in the last couple of versions of FME and give you very tight controls over the styling of those formats. Let's take a look at the Mapinfo styler. So the Mapinfo styler, and in fact all of the dedicated styling transformers, work well when you only have a limited number of feature classes to style. Otherwise, what you'll find is that you may have a number of transformers across your canvas that start to produce a little bit of clutter. We can deal with that issue with another approach, which we'll see in a moment. But for now, you can see I've created another feature. Here, the same feature is being created, but it's being offset 50 meters to the east and to the north of the original feature. Down at the bottom, I create a different type of geometry, a point, with an X and a Y coordinate. I'm then individually styling each feature. The Mapinfo styler gives me a great deal of benefit. I can colour the feature, apply the Mapinfo pixel or point width that I wish to have on my data, apply a line pattern, and this is where the styler comes into its own, because I can click inside it and pick from the standard Mapinfo options that are available to me using this GUI within FME. Once you've chosen your pattern, it will equate that into the value that Mapinfo will expect to receive. I can apply interleaving, and for my region I can apply a foreground and a background colour and also a pattern fill to my feature. Again, the patterns as found in Mapinfo. This styler has some different settings applied, and for the point I've chosen to use a true type font, Mapinfo arrows, and you'll see that I've used a north arrow and rotated it by 30 degrees and applied a halo. If we run this process, open the containing folder and drag the tab file into the already open Mapinfo and open up a map window, you can see the styling has been applied. Here's the point, and there's the coordinates that we defined. If we go back to the workbench and change the style of the arrow so that it's bold with a drop shadow, a different type of north arrow, and a different type of fill style. If we go for a different type of tree and run this process again, we can get away with just zooming out and zooming in, and now you can see the styles have changed in Mapinfo directly. Let's try the same process but with some real data. And we'll zoom extent so you can see a little bit more of the screen. Here you can see an input data, and the format is FFS. This is FME's own internal format, and it's a useful format to know about. It allows you to write data into this format, and it will accept many different geometry types, including raster data. One of the benefits is that it doesn't constrain your data type in any way. So if your attribute is a memo from Access or a varchar out of Oracle, it will retain that data type. The attribute filter is a useful transformer to split my data. I've chosen to filter on ID, and when I receive any of these values, I create a new port on the transformer to exit those features. In this case we have Belgium, France and Germany. Let's go and look at what the data is. so that we understand what our process is. Let's inspect the input. It opens in Universal Viewer and identifies the feature, and here you can see I have some European data and a country, and if we have a look at the attributes we can see it's the UK, United Kingdom, and the subname is England. Click into France and we're in the Auvergne region of France. A number of Mapinfo stylers style the features, in this case red and pink respectively, and in this case different shades of purple. If we write this process out, right click and open the containing folder and drag this into Mapinfo, we can see that we've applied some style to our data. So a simple approach to styling our data using the Mapinfo styler. Advanced Mapinfo styling takes into account the use of format attributes, which essentially is what the Mapinfo styler is helping you set. What you'll find out if you look into the format attributes is that when it comes to Mapinfo, there are a number that you can set to control the style: the brush, the pen, the symbol and the text. You can set all of these values yourself, but first you need to know what values to use. Here you can see a simple polygon with an outline border, a style, some colour. The transparency is set to false, and you'll see that the colour values are Mapinfo's representation of how that colour should be described to Mapinfo. It can at first be difficult to understand what attributes to use. So a suggestion when you're dealing with styling is that you can either go and have a look in some of the documentation that is available. These are screen grabs from the Mapinfo and MapBasic user guides, where some of the patterns and symbol styles are highlighted with the associated number that represents the right one. You'll remember this from the Mapinfo styler and the values that were described within the transformer. Alternatively, you can use FME to extract the styles you're interested in from some template data. First you need to create some template data and then create a small process in FME to extract the features. Let's have a look at what we mean. Close down the previous table. Open up a template. You can see this is the one that we prepared earlier. A polygon, a polyline, and some points, each with their own individual styles. Once we have this data, we can use it to extract the information using FME directly into a spreadsheet. I'll find my style extractor, open it up. You can see that I'm reading in the template Mapinfo file and writing out to CSV. The first transformer I'm using is the attribute exposer, and that allows me to expose individual attributes so that I can then make use of them in the workspace beyond. Here I'm exposing the symbol, the pen and the brush values. The attribute expression renamer transformer allows me, in this case, to rename all of the attributes so that I remove a prefix. Here I'm removing the prefix of Mapinfo_. This is a brand new transformer to FME 2012 and is very, very useful. You'll see that it does other things as well, and here I'm using it to change the case of all my attributes to uppercase. You can see the difference. Here, no Mapinfo prefix, and here all the attributes are uppercase. If you've used FME before, you'll know that you previously had to do that with the old attribute renamer, and you had to change the name of each attribute individually. So this is a big bonus. Let's run this, but first we'll just disable this visualizer. Right click, open containing folder, and have a look at the CSV. I've opened the CSV in Excel for ease of looking at the data, and you can see that here the Mapinfo region has a pen, some brush values, but nothing to do with the symbol. The points have symbol values, and we've extracted those style information directly into a spreadsheet. We can then essentially use this directly from the spreadsheet as a lookup, or we can use another approach and embed the information into a new workspace. If you've got a definitive data set somewhere else already, you can use this method to extract information, and it's very helpful. So, once you have your styles collated in a spreadsheet, as I said, you can either use them directly in the workspace, or you can use an approach to join to that spreadsheet and use a lookup methodology. So, the attribute value mapper allows you to hard code the styles into your workspace. The schema mapper gives you the ultimate flexibility of allowing you to style your data and store those styles externally in a format that's supported by the schema mapper. This allows you to store very complex styling information, perhaps for data sets that have rich topographic capabilities such as Ordnance Survey Master Map or Vector Map Local. Let's take a look at what we mean. Here's some advanced styling. This workspace has two flows included in it. The bottom one for the time being is disabled. We're going to concentrate on the top one. They're essentially doing the same thing, but in a different way. Here's our country data again, and we're reading that into a transformer called the attribute value mapper, which I've renamed to the foreground color transformer. It identifies the source ID out of the data, and what it's doing is assessing whether each feature is set to Belgium, France, or any of the other countries, and when it finds one that's set to Belgium, it sets the Mapinfo brush foreground color to this one here. Germany gets set to this one, for example. I then use an attribute creator which sets my constant values. The value mapper sets the variable. This one sets the constant across all the features. So the pen, color, width and pattern are all going to be the same for my features, so I use the attribute creator. Then I write the data out. Incidentally, if you want to use the FME format attributes because you're not yet familiar with this style of Mapinfo format attribute, then you can use that also. Here I've set the FME color and fill as values as well. So let's run this flow. Write it out, open the containing folder, and go and have a look at the data in Mapinfo. And here you can see some styling. If we disable the top workflow and enable the bottom one, the schema mapper joins to another spreadsheet. Let's go and find it. What you can see here is that the name of the country and the ID matches a code. So where the ID in the data matches the code column, and we get BE for Belgium, the Mapinfo brush background attribute is created and set to the column brush background, which contains a value of 128. What we can do is run this, and style our data. The data flows through the schema mapper, and if we go to the output, zoom out and in again, you can now see everything is set to blue, but we have a hatched fill on our data. Let's have a look at how this happens within the schema mapper. If you click inside, you can see that the schema mapper supports a number of formats, not as many as the total of FME, but these are formats in which you can store this kind of non-spatial data. We've chosen the Excel spreadsheet and the parameters, our Maplnfo style value. That's one of the tabs in the spreadsheet, and we're reading that in. And we're filtering where ID in the data matches the code column in the spreadsheet. Here. We're setting a new attribute, Maplnfo brush background, to equal the value that's in the brush background column. So, if we go to the spreadsheet and make a change, put a new value, into a couple of these, save the spreadsheet, close it down, and run the process again, and now go back to Maplnfo, you'll see that some of our countries have been set to green. So it's a simple approach, and it means that somebody who doesn't necessarily know how to use FME can be given a spreadsheet and can populate it with values that Maplnfo understands, and then when the workspace is run, it reads in those values directly, and it means that you don't have to hard code any information directly into the spreadsheet. So, just to finish up on this session, let's look at validating your features styling. You can use FME to validate your data, so why not validate the style? Here you can see we're passing features through the FME process, analysing each one to see what colour, symbology, pattern fill that it has, and if it receives something that is not standard or not expected or not desired, we can check it and fix it. Alternatively, we could discard it or inform the user. So we can resolve any problems or reject the features so that the user who created the feature has to reset it. So you can use FME to quality assure your symbol styles, your feature styles, as well as your data's attribution. Now let's look at some raster processing with FME. We'll focus in on clipping and mosaicing. If you weren't already aware, FME can work with raster data just as well as vector. Typically raster data is tiled. Your area of interest, though, can often be on the edge of an individual tile or several tiles. With FME, we can clip out just the data that we need and then glue the smaller pieces back together again by mosaicing it. There's a number of parameters on the destination format as well that allow us to set both compression and the creation of brand new georeferencing files. So for Maplnfo users, the creation of a new tab file is very helpful. Let's take a look at an example. If we launch FME Workbench, find the workspace that we want to look at, this raster clipping one, and we'll show the full screen so you can see a little bit more detail. What you can see on the input side is the raster tile data as a TIFF format and a Maplnfo tab file, which is a polygon of the area of our interest. Let's go and take a look. So we'll inspect the tab file first of all. Now let's add in the raster data. The first TIFF and the second. Maximize the screen zoom extents, and take a look at the area we're interested in. We turn off one of the TIFFs, we can see that the industrial area just slips over the edge of 2 tiles. What we'd like to do is clip out just this small piece. Let's take a look at how we can do that. What happens on this workflow is that we've placed a bounding box replacer to replace this polygon with its minimum bounding rectangle to give us a nice sensible feature to clip out our data with. That feature becomes the clipper. The 2 TIFF tiles enter the process, arrive at the clipper and become the clippee, the thing that's going to get clipped. If you've already noticed, you'll see that this clipper is the 2012 clipper. The reason I can tell that is not because I've named it such, but actually because it has parallel processing capabilities now. This is a preview to some of the new capabilities I'll be showing in one of my other sessions on the new features in FME 2012. This transformer chops out the pieces of data that we require, and the raster mosaicer fits them back together again. The parameters on the destination that are important are not in the user attributes or the format attributes, but under the format parameters tab. Here we can see the compression method has been defined as LZW compression. I'm not creating a world file, but I am creating a brand new tab file that gives us the new extents of our data. If we run this, it'll force some output at different stages along the way into the Universal Viewer. And you'll notice that I've prefixed my Universal Viewer transformers with integers so that they sort numerically in the visualizer. What we can see is if we look at our industrial area, we now have a bounding box for that feature, and the small piece gets clipped out of the tile on the left and the other on the right. Now what we want to be able to do is see the destination data, which we can take a look at in Windows Photo Viewer, or more practically, drag and drop the layer into the Universal Viewer, turn off all of our other data, and now we can see we have one image only, rather than having the 2 separate pieces that you can see here. So that simple exercise shows you how you can read your content, clip the features, glue the raster elements back together again, and then generate new georeferencing information. Just to prove that we have a tab file, we'll go and open that up in Mapinfo. If we take a look at the cursor location, we can see we have some X and Y coordinates in the British National Grid. Let's now look at FME as an application extender and learn how we can extend your format reach and your capabilities with FME. Mapinfo Professional users will be familiar with the Maplnfo Universal Translator that's shipped with Mapinfo for a long time now. The equivalent in FME is also the Universal Translator, or the Quick Translator, and this is a screenshot of both applications. There's some differences between the 2 capabilities, and I'll highlight those now. The Universal Translator in Mapinfo has a restricted format capability, but it allows you to translate DWG, DXF, EOO, Shape, DGN, SDTS and VPF formats through to Mapinfo Tab or MIDMIF. You can also take MIDMIF and Mapinfo Tab files and translate them to the AutoCAD, Esri and MicroStation formats. But you'll see that you can only pick up the projection that's on the source data. You can't reproject the data during the process. When it comes to FME's Universal Translator, or as I mentioned more recently referred to as the quick translator, the format reach is over 275 formats. You have control over splitting the data or conflating it if required. You can also reproject the data from its source coordinate system. One hidden capability that isn't always noticed straight away is that the Universal Translator can also run FME workspaces, even without a password should the workspace be protected. This means that you can pass workspaces to colleagues who are less capable with FME, or perhaps you want to protect your work, and they can still run it using the Universal Translator without you having to give them the password. Let's just take a quick look at how you can get access to the Universal Translator in Mapinfo. To find it, all you need to do is launch Mapinfo, go under the Tools menu, and you'll see the Universal Translator is available. If it's hidden, the Tool Manager allows you to scroll through and find the Universal Translator. There it is. And load the tool. This will then allow you to see the Universal Translator and launch it. And you'll see that I can now minimize Mapinfo, and it's available to use independent of Mapinfo Pro. Once you've worked with the Universal Translator though, the next step is to consider the next capability, and that's Open Universal Data. This is a more recent introduction. It's been available in Mapinfo since version 9, and it gives you free access to an extra 9 data formats. Normally, we would go to Open Data in this way. However, we're going to use the Open Universal Data option to launch some data instead. FME users will be familiar with this dialog box because it's very similar. Here you can see the 9 extra formats with 2 greyed out. They're greyed out just because I don't have any Esri technology installed on my system, which means I don't have an available license. If I did, they would be available to me. I'm going to choose to open up AutoCAD data, specify a file location. I've got a DWG available on my machine, and if we click on the file and open it up, it reads the schema of the data, identifies all the layers inside, and I'm just going to choose to bring in a handful of those layers. I'll use the colour information already in the DWG and make sure that I save it out to an appropriate location. What I'll do as well is find that location so I can show you what happens. We'll run that now, and you can see that what happens is that FME identifies that the DWG has no coordinate system in it, so we'll set that to the system default because that's where the data is, and now it slowly reads in each one of those files. You can see that Mapinfo is pulling that straight out of the DWG, and a tab header file is created for each layer inside the drawing. These are essentially connections directly to the DWG file. Let's maximize the view and look at the whole layer. So, several layers in Mapinfo. If we zoom in, we can see a little bit more detail. The beauty of this process is that we can now close everything and now use the conventional method of opening a table. All these tab files are created, put them all into a current map window, and you'll see a flash as the connection is made to the DWG. And there's the data again. FME has an integration console and it was previously called the Administration Assistant. It's definitely worth looking at, because it's not always something that you'll see straight away. It's very relevant to MapInfo Professional users because it's the way that we can extend MapInfo with FME's license. Rather than having access to just 9 formats, we now have access to hundreds of additional formats directly within MapInfo. First, we need to close MapInfo down. Then go to Start, All Programs, find your FME installation, and look inside the utilities. As I mentioned, it'll either be called the Integration Console, or if you're on an earlier version of FME, it's called the Administration Assistant. Generally, when you launch the Integration Console, you'll find that it will work straight away, but in some cases you may need to launch it using the Run Administrator options. I'll do that now. Here you can see the Integration Console, and it tells us what versions of software we have that could be extended by FME. In this case, I just have the one, MapInfo Professional. Let's extend it, and you'll see that now the FME build that I have installed is extending MapInfo Professional. That's the Integration Console's job done. If we start and find MapInfo Professional and launch it, we should now have the option of going to Open Universal Data, but this time, rather than 9 formats, we have access to a great many more. This capability extends the format reach of MapInfo and allows you to get access to lots of other data. Now that you know that that's possible, we can take it one step further. You can build a format of your very own. You can do that if you've got uniquely structured data, or perhaps you have some very complex processes that you want to bundle up behind the scenes. Also, if you have to process that complex data frequently, it can help to build a custom format. The benefit is that you can share these formats with colleagues. Alternatively, you can just become more productive yourself by having a pre-processed set of instructions stored as a format. Let's take a look at a capability we have described using an ambulance route, which is a GPS process in FME. First, I'll launch FME. Open up a workspace. And zoom extents so you can see the details. Here I'm reading in a CSV file. Let's open it up and see what it contains. We have an ID, a route number, a grid reference, X and Y coordinates. If we close it, we can now have a look at how that data is being processed. The first thing that happens is that the CSV's values get set to British National Grid. We know the coordinate system is British National Grid, however the data set is specified with no geometry or null geometry, and we need to set those features to the right coordinate system so that when we use the 2D point replacer to set the X and Y and create points coming out of here, they know where they are and they're positioned in the right place. We're then going to sort the attributes by ID and route number. The point connector allows us to join the dots, and what we're going to do is every time we get a different route number, we're going to break the line and create a new one. We should then get several lines coming out of here rather than all of the nodes being connected to each other. We're then going to reuse the MapInfo styler that we saw earlier on to style our features. Down here I'm temporarily reading a little bit of OS Master Map so that we can have some context for our route. Here I'll run the process, and the majority of this process is reading in the topographic data. and yet it's only just under 6 seconds to carry out that process. Let's maximise the view, turn off the master map data for a moment, and also we'll remove the route. The CSV file was read into FME, and we created a series of points. If we look at the route and select one of the links, we can see that at certain intervals the line is broken. That's where the route identifier changes. So, turn on the master map data, turn on the route, and we have some context to our ambulance journey. So, if we go into this section, we don't necessarily need to delete the data, we can just disable the objects inside the bookmark. Now if we save the workspace, choose File, and export this process as a custom format, this will give us greater access to the data and the process. We need a description, and now the custom format will be exported to its own unique file, and this file format is a .fds file. You'll see that that's the location if we go and find it. There it is, and that could be put on the network and shared with colleagues if you wish. So, if we now close all our instances of FME and then launch FME again, it'll recognise that that custom format now exists. If we wanted to add a new reader, we could now search for GPS, and you'll see that our CSV process exists. Oddly, when we choose a data format, it prompts us that we need a CSV, and that's because our custom formats input is CSV. Bring in our ambulance route, add it onto the canvas, and now we have our GPS CSV custom format, which has our route and ID number. If I right click, connect an inspector, and run this process, what we get into the visualizer is our output data already formed as a polyline, or a series of polylines. So essentially what's happened is that behind this custom format, a workspace is run, which produces the output that comes out of here. The benefit now is that there's quite a series of transformers and processes that get us to this stage, and we don't need to show that every time. So if you have a repeatable process, this can be very helpful. Let's go and have a look at Mapinfo now and see how that can benefit us over there. If we just go and choose the option to open Universal Data and search for our custom format, you'll see it's available, and we can pick our CSV as our input format. The benefit here is that we've basically given Mapinfo our FME license to use, and what we can do is read in this custom format. We want to use the colour information that's created by our Mapinfo styler, deposit the output, header tab file in an appropriate location, click OK, and bear in mind we're in Mapinfo now. We've chosen to read in a CSV file, and what we get is an FME process run behind the scenes and a series of polylines shown to you. So as a Mapinfo user, you've just run FME without realizing it and without having to carry out a complicated process yourself. So, thank you very much for viewing this session. If you'd like to find out more, go to onespatial.com and click on the FME Desktop or FME Server pages. If you want to evaluate FME, you can download the products from either page. You can comment on this training or ask any questions by emailing fme@onespatial.com. This recording will be available on OneSpatial's website and a number of other resources. If you'd like to find out more directly from Safe Software, go to safe.com or fmepedia.safe.com, where you can have access to all of the other online resources. FMEpedia has lots of information that you can review or download. FME Talk is a Google group for chatting to other users. The FME Evangelist blog gives you tips and tricks, and the YouTube channel FME Guru gives you other videos like this one that can help you along your way. For now, thank you very much, and here's my contact details if you'd like to get in touch directly with me. My name's David Eagle, Principal Consultant at OneSpatial.